Hello, everyone. As Brandon said, my name is Christella, and I am now an iOS engineer at Kickstarter. And before joining the native team, I was a student at C4Q's Access Code program. And this is a program that prepares adults with the skills necessary to be entry-level programmers. And so prior to the summer, I had never built programs using functional reactive programming paradigm. In fact, most of the programs I've built use the object-oriented paradigm, programming paradigm. So naturally, when I was learning about functional reactive programming, I thought that it was a very different way about thinking on structuring programs. And so today, I would like to make the case in objecting to objects on why you should consider this paradigm to build your programs and how you can do that. So one of the things that I learned that I enjoyed about working with OOP was how relatable it was. And OOP, as you all know, uses this idea of objects. And objects have properties and attributes and methods, and they also interact with each other. And this concept reflects the world we live in, where we interact with objects, and we can see objects interact with each other. And like the objects in our world, objects have certain qualities to them as well. And so in addition to making our programming relatable and easy to understand, OOP has also contributed to making our programs more modular. And modularity is a good thing because we can write code faster, and it is simple to reason about our program this way, but the benefits of OOP end there. And this is because objects interact with each other, and that this means that they often rely on methods that change their internal state. And this exposes your code to side effects, and side effects add complexity to your code, making it difficult to maintain, reason about, and test, because you will essentially have to handle these side effects sooner or later. And so I say all this to say that maybe when approaching structuring our programs, we should consider a more reactive approach. And we can do this with functional reactive programming. Instead of using the idea of objects to guide how we structure our programs, I think that we should structure our programs in terms of inputs and outputs. And I think that for many, this may sound like a less approachable way in comparison to objects, but it is much more simpler and can still be relatable. And once I started using functional reactive programming, I had to view programs in terms of what the user is doing and observing, and less about objects encapsulating state. So in functional reactive programming, we use this idea of signals instead. And signals are a component of reactive programming. This means that you're going to need a reactive framework to be able to use this component. And so the framework that we use is Reactive Swift, formerly known as Reactive Cocoa, but you could also use RX Swift. And what I will be discussing is also going to be applicable to RX Swift as well. So a signal is a stream of events that can be observed over time, and we can use signals to model inputs and outputs. So as you can see here, this is a signal that emits a value of integer. So first it's going to emit 1, and then after some time, 2, and then after some more time, 3. And so we want to think of inputs as what the user is doing, meaning user actions received by the system. An example of this includes a button tap or keyboard text. But I also want to note that view controller lifecycle methods are also hidden user inputs, and we refer to them as such because they are not what you would typically think about a user on user actions. And for example, the view.load method is called because the user did something to get to that view, and it helps in configuring the initial state of our programs. And so here we have an example, and our input is going to be a user text for an email. And we use the signal.pipe function to lift user actions into the signal. And so now we want to think of outputs as what the user is observing, meaning actions sent by the system. And some of these outputs, an example of outputs are setting a button as enabled, setting labels as hidden, and setting a view's background color. And so here we have an example of an output signal. And output signals have, this output signal has a Boolean value because this is how we determine whether or not to enable the button. And so we derived our output signals from our input signals. We're using the .map operator on our input function to figure out if the text field has at least one character. And if it does, then we enable our button. And lastly, we use output signals to determine whether or not our button is enabled. So performing the side effects in the view. So object-oriented programming is still imperative. In our methods, we still have to describe objects, how these objects will behave, and these methods change the internal state of our objects. And in many cases, we still have to determine the order in these methods will be called. And so what functional reactive programming allows us to do is avoid side effects by creating input signals, performing operators, which are pure functions, to get output signals. And operators are declarative, so we don't focus on procedures. And it also makes our code readable because we know we're going to transform the signal input that gives us a signal output, making it easier to test our code. And all this results in us being able to reason about the correctness of our code easily. And I think that our goal as programmers is to make sure that our code is correct and maintainable. And so the struggle that comes with shifting your mindset to functional reactive programming from object-oriented programming is definitely worth it. And so here are some resources that helped me learn functional reactive programming. The first being reactive Swift documentation, particularly the design guidelines, because they suggest the best practices for using reactive components with signals, like signals, and an interactive diagram of reactive Cocoa. Here you're going to see diagrams of signals and the effect that operators would have on them. Next is based on my experience, learning, the best way to learn functional reactive programming is to actually do it. And so I would like to recommend a talk by my colleagues Lisa and Gina from last year's conference in Budapest. And they basically show how you could take a program from object-oriented to functional reactive programming. And they also go over testing as well. And so the Kickstarter codebase is also a good source. It's a real-world example of how functional reactive programming works. Simple Made Easy by Rich Hickey. I use words throughout my talk like simple, easy, and complicated, which is based on how he defines these words in his talk. And lastly, Why Functional Programming Matters by John Hughes. Hughes makes a compelling argument in this paper on how higher order functions and lazy evaluation bring our modular programs together. So thank you, and yeah.